Hi guys, this is your teacher again. So we are going to pick up where we left off from our last video notes. This is still 2.1. We're going to continue with example 3 and we are going to try to finish G and H, okay? And then we're going to see how far we can go within about 25 minutes worth of video notes. So here we go. Last time I remember I divide this up to two sides, okay, so we can neatly organize our notes. Remember, you have to do notes in a way that you understand it and in the way that you can read it. So here we go. We're going to pick up G. So G wants us to find f of x plus 3. So our original function, which I'm going to move down, it's f of x equals negative 3x squared plus 2x. So instead of an input being just a single x, our input now is x plus 3. Okay. So anytime and every time I see an x, I'm just going to have an open parentheses, and I'm just going to fill in my new input right there. Okay, so I have a negative 3 times x squared, so now I don't have an x squared anymore. I'm going to leave that blank, plus 2 times x. Again, I don't have that x anymore. I'm going to leave it blank and fill in my new input. In this case, it's an x plus 3. Okay? And that's how you do these type of problems. So with that said, we are going to, remember, an exponent of 2 means I have 2 of these. So if you don't remember, write it out twice. Okay? Because you will need to distribute these. Then I'm going to distribute my 2 because that's a binomial times a monomial. That's just going to give me 2x plus 6. Now I'm going to distribute this binomial and a binomial. So I'm going to bring down my 3. I'm going to distribute that last. X times x is going to be x squared. X times 3 is going to be 3x. 3 times x is going to be another 3x. 3 times 3 is going to be 9. Close that up, and I'm going to bring down my 2x plus 6. Okay, 2x plus 6. Alright, then now I'm going to see if any like terms can be combined, which is in the parentheses here, which we do have. I'm going to bring down my negative 3 again. I have x squared plus 6x plus 9. Close that up. And again, bring down my 2x plus 6. Distribute my negative 3. I'm going to end up with negative 3x squared. Negative 3 times 6x is going to be minus 18x. Negative 3 times 9 is going to be minus 27. Bring down again my 2x plus 6. Okay. There is not another negative 2x squared term, so we are going to bring that straight down. But these two are common or alike, so we're going to combine them. Negative 18 and a positive 2x is going to be a negative 16x. And these two are alike, so we're going to combine them. Will give us a negative 21. So f of x plus 3 equals negative x squared minus 16x minus 21. Okay? And again, if we are going at a faster pace than you can write, then just hit pause and finish writing before we go on. Okay, before you go on. Alright, H, last one. This is what's called a difference of quotient. Okay? Difference means there's a subtraction sign, and then quotient means a division problem. So difference of quotient. And the reason it's always going to state that h can never ever be 0 because h is being divided by h. Okay, so for this one, we're going to do multiple steps. The first piece I'm going to do is f of x plus h. Okay, so let me write this down real quick, the whole problem. So find the difference of quotient, which is f of x plus h. Difference means subtract. F of x, then all of it divided by h. Okay, we are going to break this up. We will break this in two parts. Excuse me. So the first part I'm going to accomplish is f of x plus h, which is very similar to f of x plus 3. I'm going to do exactly the same thing, except now I have x plus h instead of x plus 3. So here we go. Anytime I see an x in my equation, I'm just going to substitute it with x plus h. So we have negative 3. I see an x squared, so I'm going to write in x plus h squared plus 2 times x, which my input is now x plus h. Okay. I'm going to write this out twice on the bottom here so I can distribute. So bring the negative 3 down. X plus h, write it out twice, especially if you keep forgetting what the power square mean. It does not mean it's x squared plus h squared. That would be a big no-no. Okay, so just write out twice and then we will distribute that later. So I'm going to distribute the 2x and the 2h. So bring down the 2x and bring down the 2h. So now I will distribute this, okay? So bring down my negative 3. X times x is x squared. X times h is just simply xh. H times x is simply, again, xh or hx. Does not matter how you write it because multiplication is commutative. H times h is simply h squared. Okay. So now we have this piece. I'm going to bring down my 2x plus 2h. If I can squeeze that in there, 2x plus 2h. Whew, that was close. Then now I'm just going to distribute my negative 3. Or you know what, let's combine like terms. So let's have x squared, xh plus another xh is 2 of those. And then bring down my h squared. And then now bring down my 2x plus 2h. Distribute the negative 3. So negative 3x squared minus negative 3 times the positive 2x is minus 6xh. Negative 3 times h squared is negative 3h squared. Bring down 2x, bring down 2h. Alright, now earlier we were able to combine a couple of these things in example G. But because this is the square power with an x, this is square power with an h, we can't combine those. This has an hx in it, this has an x only, and this has an h only. So none of this can be combined. Okay, so that is our first step. The second step is we're going to put them all together. We don't have to do any more individual work. Now we can just subtract f of x. Now keep in mind, f of x is our original function here. Okay, so we are going to subtract the entire piece and then divide it by h. So here we go. So we're doing an f of x plus h, which is this whole piece right here. So we are going to use, I'm going to use a pencil, or you know what, even a red pen, so you can see what I'm doing from here. So the question wants us to find the difference of quotients. So that means it wants you to take f of x plus h, which we found an answer, which is negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h. Okay, that is just this piece. Now we are going to subtract the original function, which is f of x, which, as you remember, it's still on your paper, negative 3x squared plus 2x. So, but then when you're subtracting, you want to put parentheses. See this right here? Want to put parentheses around the entire piece. Okay? Because you're not just subtracting one term, you're subtracting the entire function, f of x. Okay? And then all of that is divided by h. Okay? Then what we're going to do is we're going to distribute this negative. This is why it's so important for you to put parentheses around all of f of x. So distribute my negative. Let me just copy this first few things down because there's nothing here in the front to distribute. Okay? So a negative and a negative, that will give us a positive 3x squared. Negative and a positive 2x will give us minus 2x. And I might run out of space, so I might turn to the back, okay? And then divided by h. So if you look at my negative 3x squared and a positive 3x squared, those will be canceled out, okay? Then if you look at my negative 2x and a positive 2x, those also be canceling out. So what I'm going to end up with is negative 6xh minus 3h squared plus 2h. All of that is divided by h. Okay. Now look at the numerator. Is there anything that it has in common? Each and every term on the numerator has an h in common. So we are going to factor it out. So factor out the h, I'm going to end up with negative 6x minus 3h plus 2. All of that is going to be divided by h. Okay. If you have an h on the numerator divided by an h on the denominator, you are going to you can cancel that out. Okay, so are going to cancel out. And guess what your final answer is, which I'm going to try to squeeze that in there, okay? My final answer is just simply negative 6x minus 3h plus 2, okay? Right now, this process does not make sense, okay? Like, why are we doing all this work? But when we get to calculus, it's going to make so much more sense why we do this one, okay? So right now, think of it as just procedure, okay? I want you to do this, and there's no application for it until we get to calculus, okay? And again, this is so important. If you didn't get it the first time, go back and re-listen to just this one if you didn't get it. All right, that was intense, right? Starting out. All right, so since we have been hearing about this giant moon or this, super moon, let me just tell you a toddler joke before we proceed to the next example. How do you know when the moon has enough to eat? Okay, how do you know when the moon has enough to eat? When it's full. When it's full. Welcome to my 4-year-old life. All right, let's move on to our next example. Okay, here we go. Example 4. Find the domain of the following function. Okay, so if you remember, if you're looking for the domain, which is a set of all x values, okay, so domain is a set of all x values. And for it to be a function, remember, there can only be one output for one input, okay? The output's got to be unique. So let's find the domain, which means I want to find what are every single x value possible. And if you remember, if there is a couple of things that it wants you to know. So let's read this piece, and then we can go on, okay? This is right at the bottom of your example 4. Finding the domain of a function defined by an equation. That means given an equation versus a graph. Start with the domain as a set of all real numbers. So that's what it wants you to do. Every single equation, assuming it's a function, okay, in this case it did say it's a function, we're going to start with all real numbers. If the equation has a denominator, exclude any number that give a 0 denominator. If the equation has a radical or even index, okay, that means a square root or a fourth root or a sixth root, exclude any number that caused the expression inside the radical to be negative, okay? So there are only two things you have to worry about when you're looking for the domain. Number one, you need to look to see if there's a denominator, because the denominator can never, ever have a 0, and the denominator can never ever be 0. Number 2, you're going to look out for radical, because radical cannot be negative inside, okay? So what we're gonna do now is we are going to start with our box, okay, of answer first. How about that? We're gonna say, hey, this is the domain. It's all real numbers. But because there is a denominator, we're going to say except, and then let's find out what we need to exclude, okay? So we're going to take the denominator, which is x squared minus 2x minus 3, and we're going to set it equal to 0 because we're going to exclude what makes it 0. From here, we're going to try to factor. If it's factorable, if it's not factorable, you might need to use a quadratic equation. So in this case, we are in luck, right? It's, let's say, x times x, so it will give me x squared. I'm going to need to have I'm going to need to have a factor of 3. So 1 times 3 is 3. And I need to have a negative in the middle, so I know this has to be negative and this has to be positive. All right, let's check. X times x is x squared. X times negative 3 is negative 3x. 1 times x is positive 1x. 1 times negative 3 is negative 3. If I add up these two middle terms, it will give me my original, so check. All right. So now that I've already successfully factored out, I'm going to take each factor and set it equals to 0. Remember, we're trying to solve for what value or values of x that we need to exclude from the denominator. All right, solve for x, subtract 1 from both sides. X equals, oops, I'm sorry, this is supposed to be 1. Subtract 1 from both sides, so x is -1. Add 3 to both sides, x equals 3. All right, so these are the two x values that we will exclude, okay? And the reason we are excluding them because these make the denominator 0, which we can never ever have. So we're going to write all real number except -1 and 3. And you know what? I need to do a bracket, not a parentheses. Okay? So if I need to draw this on the number line, here we go. Here's -1, here's +3, excuse me. I can have every single number except these two locations. So if I said, hey, graph out your answer set on a number line, I'm going to be shading everything except two big holes on those integers. Okay? And so now that we are in pre-calculus, we might need to learn this interval notation, which you're not required to know by now, but you are going to be required to know soon. So if you look at this, it's going from -infinity over here to a -1. So this is another way of writing your domain. It's going to go from -infinity, oops, which I just wrote -1, -infinity, okay, -infinity, comma, -1, okay, or, which when I use union, okay, union that, the U means or, -1 to 3, -1 to 3, or we can go from 3 to infinity. So 3 to infinity. Okay. So this is a new notation. It's called interval notation. Okay. This is called interval notation. That means I'm saying, hey, the domain is from here all the way to here, -infinity to -1, not including. And then -1 to 3, okay, not including the endpoints because it's a circular bracket. And then 3 to +infinity, so that's what it means. Or you can just write out old school. All real numbers except -1 and +3. All right. Now that I've invaded a little bit of a space here, I'm just going to make a line, okay, just to keep myself nice and neat. All right, example B. Find the domain of example B. Now let's talk about what our answer should be. Question number 1. Q1. Does it have a denominator? Okay. If you said no, it's a good thing. That means the domain, it's going to be all real. Question number 2. Does it have a radical? Okay. If you say no, then now you can totally write your answer because the answer is certainly all real numbers because we don't need to exclude anything. Remember, the only time you need to do any math at all is when it has these two. Or interval notation, ready? All real numbers mean from -infinity all the way to +infinity, all right? So we're kind of getting to our new notation, which is the interval notation. Okay, here we go. Example C, find the domain. Let me again make more space and get myself more organized here. Okay, find the domain of h of x equals square root of 3 minus 2x. Okay, now if you look at this, we do have a radical, so we have to be very cautious, okay? Because we can never, ever, ever have a radical, a negative under the radical. So what we're going to do is going to take this under the radical, okay? and we are going to set it equals to 0. And the reason we are going to set it equals to 0 is because we are going to decide what makes it negative, okay? And what makes it negative is because I don't know what the first negative number is going to be. Some people might pick -1, some people might pick -2, some people might pick -half, -0.0001. So we can't really just go and pick a negative number, so we set it equal to 0, okay? And then we're going to add 2x to both sides. So 3 equals positive 2x. Divide both sides by 2, okay? So x is going to come out to be 3 over 2, or 1.5. Now we are not going to exclude 3 over 2. So 3 over 2 is a positive number. So this is 1, this is 2, this is 3, this is -1, this is -2, okay? What makes it 0 right now is 1.5. But we want to exclude things that make it negative, okay? So my question to you is, when I put, can I have a square root of radical 0? What is square root of radical 0? Can I have it? The square root of radical 0 is 0, right? Which means it's okay to have, okay? So at 1.5, it's a closed circle, okay? Because I can have 1.5, okay? The question is, can I, now you have to test. Pick a point. Pick a point on the right of the value you've just solved, okay? And pick a point on the left and plug it back into the equation. So here we go. I'm going to pick 3. 2 times 3, okay, I'm sorry, -2 times 3 is going to be -6. 3 minus 6. Okay, so here we go. Check. Let x be 3. Okay, so we're going to write, hey, h of x equals radical 3, take away 2 times, I'm picking the value of 3, which is equaling out to be 3 minus 6. Is that a negative number or a positive number? 3 take away 6 is going to be a -3. This is a negative number. So we're not going to have any solution to the right of 1.5. Then let's pick a value on the left. You can pick 1, 0, -1, -2. Okay, so let's pick the smallest value, or the easiest value, I should say. It's going to be 0 to choose. I love 0. I mean, why would you not? Because anything multiplied to 0 is 0. So we're going to pick 0. 3 minus 2 times 0 equals 2 times 0 is 0. 3 take away 0 is positive 3. So if I pick values on the left, notice how it's going to come out to be positive, which is what we need, or what we want, excuse me. I'm losing my voice. Therefore, we are going to shade in on my number line this way, okay? So my domain is -infinity to 1.5. So that's how I'm going to write my answer. Here we go. Excuse me. Domain, we're going to write old school way first, okay? So domain is x is less than or equal to 1.5, or actually I love writing fractions, so let's just keep it as fractions. Oops, you can't see that. Whoop, there you go. Or new notation, okay, from our number line, as you can tell, is from -infinity all the way to 1.5. So -infinity to 1.5, or 3 over 2. Notice how I'm really flexible on how you're writing your answer. Now, different notation. I'm going to use this square bracket. Okay, and let's talk about the square bracket. The square bracket means I am including 1.5 in my domain. Notice how like this is inclusive? So that's why this is a square bracket. Now earlier, I want to come back to the other notation. Notice how like over here we have circular brackets, okay? That means these are open circles. That means I'm not including those end values, okay? That means -1 is not in my domain and 3 is not in my domain. Versus if I'm using my interval notation and I'm using the square bracket, that means the square bracket means yes, I do want 1.5 or whatever this value is back here in my domain because it's a closed dot. Okay, square bracket means closed dot, inclusive. Okay, circular brackets meaning open dots, not included. All right. Okay, Dookie. This is the end of our lecture. I will see you next class. Have a wonderful day.